guys, it's Miss Davis again. In this presentation, we're going to go over our measurement and conversions part 2. These are the notes from September 21st that we did in class. This is where we convert in between metric and English units, and then we can go back. So, for our bell work that day, we just had a warm-up question of how many liters are in 2,342 milliliters. So I drew half of our conversion chart here. So we're trying to go from milliliters, because that's what's given to us, and we're trying to get back here to liters. So if we start with our decimal place, we're going to move it 1, 2, 3 places to the left. Do that here. So our final answer for our warm-up question was 2.342 liters. And if you're not sure how I got that, make sure you look at the last set of notes that I created for you guys for a tutorial on that. Here you are to practice with a partner so you can actually check your work. I am going to put the answers up on the screen, so check your work, see how you did. If you have questions, you can come see me. So if you go from 15 centimeters to decameters, that is 0.015 decameters. Okay, 97 hecto to kiloliters is 9.7 kiloliters. Decagrams to decigrams. 2 decagrams is equal to 20 decigrams. And then 0.35 kiloliters is actually equal to 350,000 milliliters. And when you got to number 5, I told you to look very closely here because 25 milligrams, we can't convert that to liters, at least not right now. We'll actually learn how to do that a little bit today, but this one's actually impossible. You can't do this one as of right now with the information that you already have. Okay. So the first thing we're going to talk about are temperature scales. We are very accustomed to using Fahrenheit here in the United States, but every other country will typically, as its normal degrees, we'll use Celsius, and then in science we actually use Kelvin. So don't forget temperatures and measurement of how hot or cold an object is. In physical science, you learned that really fun word, kinetic energy, and that's just the amount of motion that particles or atoms have. So everything's made of matter. If an object has a high amount of kinetic energy, we will perceive that as hot. If it has a low amount of kinetic energy, we will perceive that as cold because it's trying to steal your energy. Okay, so again, scientists, we use 2 units of temperature. We use degrees Celsius and Kelvin. Notice we don't ever use degrees Fahrenheit because that's something that is just typically used in those 3 countries stated before. Burma, Liberia, and the United States. Everywhere else won't typically use Fahrenheit. Okay. If you're trying to convert, though, between the two, if you are trying to get to Kelvin and they give you degrees Celsius, you're just simply going to add 273. And vice versa, if you are trying to get to Kelvin, that's what's given to you, and you're trying to get to degrees Celsius, you just subtract 273. So we're going to do some example problems here. Okay. So if you have 65 degrees Celsius and you're trying to get to Kelvin, because we're going Celsius to Kelvin, we are going to add. So we're just going to take our 65 plus 273, and that will give you 338 Kelvin. Notice I don't say degrees Kelvin because there is no such thing. It's just Kelvin. So don't ever write that degree sign. Otherwise, technically, your answer is incorrect. So make sure you try these 2 problems. I am going to put the answers up here on the board, but now would be a great time to pause the video, try it, and then check your own answers. So if we have 365 Kelvin and we're trying to go to Celsius, Kelvin to Celsius, we are going to subtract 273. So if you take 365 minus 273, that will give you 92 degrees Celsius. In our last problem, 940 minus 273 will give you 667 degrees Celsius. Okay, so how'd you do? Let me know. Talk to me in class. Okay. All right, now for the fun stuff. So dimensional analysis, that's what you're going to learn or what we're going to review here. And basically what this is, it's a way to solve and analyze your problems using units of measurements. It's basically going back and forth between our metric measurements and our English measurements. Okay. So I gave you all of these conversion charts. So if you lost that, now would be a great time to write these down. You can pause the video, write down what you need. But here are our imperial or our English units. Metric units are going to be on the right. We've got our volume units here. And then we've got our mass, or excuse me, our distance or length units at the end. Okay. Now how we do this, there is a few steps that you can go through. So the first step, you start with the beginning unit on top of our railroad track. Then you're going to measure, or you're going to match the top units to the caddy corner units so that they cancel out. So whatever is in, so if we have our railroad tracks, whatever units are here, they should also be down here so that they cancel out. You will convert to your converting unit on top, so we'll call that converting units. Anything that is next to each other, you will multiply, and here would just be a 1 because it's empty. And then whatever you get, you will divide by. Okay, and I'm going to show you exactly what I mean here. So if we have our railroad tracks, okay, so if we have our railroad tracks here, we have our starting units. So this was step 1. Start with what you're given. Then starting units go on bottom. So these should be, let's say you start with 14 grams, and we know that 2.54 grams equals 1 ounce. Okay, so that grams would go down here again. Starting units conversion. Okay, so that these would cancel out, is equal to whatever our converting unit is. And then if you need to keep going, you can actually use these also. But whatever two numbers are in these boxes, you will multiply. If there was another unit in these boxes here and here, you would still multiply all the way across. You would multiply these two across. And then you would take answer A divided by answer B, and then your final units are whatever units are not canceled out. So typically it's whatever's in this box here. So these are ending units. We're going to practice, so don't worry about it. Okay. All right. So our first one is to convert 740 centimeters to inches. And if you look at your conversion chart, we know that 1 inch is equal to 2.54 centimeters. So if we're starting with 470 centimeters, so this is our step 1 because that's what's given to us. Given will go in the first box. Create our railroad tracks. Now we're going to use our converting units, or our converting number, 2.54 centimeters. Don't forget that so that we can cross it off here in a second. Is equal to 1 inch. And this is what we're trying to get to. Inches, inches, they equal out. So we're going to cancel those out. 470 times 1 is just 470 divided by 2.54 because it's the only thing on bottom. So if we take 470 divided by 2.54, we will get 185.04 inches. And that's your final answer. So this next one, I actually want you to do on your own. And again, I will put the answer up, but I want you to try it first, see how you do, then continue hitting play. Okay. So if we have 90 fluid ounces, so we have 90 fluid ounces, and we're trying to get to milliliters. We know that according to our conversion chart, 1 fluid ounce is equal to 28.6 milliliters. And this is what we're trying to get to, what we're getting to. Cancel, cancel. 90.28.6 is 2,574 divided by 1. So our final answer here is 2,574 milliliters. Do not forget your units, otherwise it is half wrong. Again, I want you, or this one I'm going to show you how to do it. This is a two-step process. So much in the same way that if you are, let's say you're taking a bus or a train or a flight somewhere, sometimes we don't have a direct flight like we did with the last ones. We have to have somewhere where we have to stop, and it's something that we have in common. So this first one, when we're trying to convert grams to pounds, our conversion charts didn't just have something that said grams to pounds. We know that we can go from grams to kilograms because of our original conversion. So this is what we learned on day 1 of conversions. And then we can continue going to pounds because that's what was given to us later. Okay, so kilograms is our common ground here. So the first way I'm going to show you, you just simply have to move the decimal like we've done before. So if we take 735 grams is how many kilograms? We're just going to move our decimal 3 places to the left. So we get 0.735 kilograms. Now this is our new starting unit because we've already converted our grams. So if we take 0.735 kilograms, and we know that 0.45 kilograms is equal to 1 pound, we plug that into our calculator because 0.735 times 1 is just 0.735, and we can cancel our units here. Our final answer is 1.63 pounds. Okay. Now there is another way to do this, but I will show you in class where you do railroad tracks the whole way through. And if you think you can figure it out, then go ahead, give it a try. But this next problem is, again, a 2-step problem. I want you to try it, see how you do, and we will check this one in class. So make sure you guys practice, and if you have any questions, please feel free to email me, remind me. You can go to the Facebook group, whatever you need to do, but I will see you in class. Have a great evening.